Notation is essentially shorthand for long numbers. Now, long numbers can either be like really giant, like, billions of billions long, or it can be really long string of decimal, like 0.00000 something. Yeah. Yeah, long strings. Basically, it's a long string of numbers, and this is a way to write it so you don't have to write the whole long string. Okay. So standard form is your basic number. Okay, so like that would be standard form. Or you could have something like that. Scientific notation is a shorthand to represent the same number.
What's the amount of zeros you have towards the decimal?
Well, you have the exponent. Decimal has an I in it. So the exponent is equivalent to the number of spaces you move the decimal. So if we look at this first example, if there is no decimal, the decimal's right here, yeah? We always
That's 5 trillion, right?
hold on, hundreds, thousands, 100,000, wait, 100,000, millions, billions, trillions, yes, 5 trillion. Okay, so we always move the decimal to after the first non-zero digit counting from the left. So starting here, my first non-zero digit. Starting here, my first non-zero digit. Does that make sense? And because we're doing a shorthand, we do a maximum of 2 decimal places in the final. Okay, so we start at here, and I want to move to here, because that's after the first non-zero digit from the left. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm moving 12 places, right? 5.63 keeps the 8 and 8. So 6, 8. It's always times 10, and then this is the number of places you moved. This is the scientific notation. That means you don't have to write all of that.
Where does the 10 come from again?
Because the 10 to the 12 gives me these 12 decimal places back, or these 12 place values back. 10 squared is 100, 10 to the third is 1,000, 10 to the fourth, 10,000. So whenever you have a 10 to an exponent, it tells you how many zeros there are. So if I were to take this and multiply it back out, I would get 5680000000000.
Well, times.
Yeah, but so basically we're rounding. It's a type of rounding. But we're rounding without having to write all of the zeros. This is all of the zeros. In the final, yeah. So you only have, so here, 2 decimal places. This 12 gives us that. If I look at the long decimal version, I go 1, 2, 3, 4, 5, 6, 7, 8, 9 after the first number that's not a 0. And that's where I got this.
And the zeros are before the numbers are also negative, right?
It's a negative because it's a long decimal.
Mm-hmm.
If it's a positive, you have a long number.
Mm-hmm.
If it's a negative, you're having a long decimal. Basically, your exponent, if you moved left, exponent is positive. If you moved right, exponent is negative. So, or you can think of it as a big giant number, positive exponent, itty bitty 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 tiny number, decimals, right? Long strings of decimal. So itty bitty tiny number, negative. So if we look at this, we're going to put this into scientific notation. I have a big giant number, so my decimal's at the end. I'm going 3, 6, 9. 9 places, right?
Mm-hmm.
So this will be 3.4 times 10 to the 9th. I'm going to actually write them down here. Number 2, my decimal is here, so I'm going 1, 2, 3, 4, 5, 6, 7. So it's going to be 3.12 times 10 to the negative 7, because it was a big decimal. Yeah.
Sorry. On that first one,
Mm-hmm.
why is it going to be 3.4? Why would it just be 34 times?
You don't. It's always after the first not 0 number. So it's never 34. It's 3.4. You only want a single digit before the decimal. So here, 3, 6. Now in this case, I'm just going to end up dropping off the 1 because the 1 doesn't change the 9. So it'd be 2.09 times 10 to the 6th.
No, on 3, are we going from right to left?
Yeah, because we start here.
Okay.
So we go 3 and then 6.
Oh.
Okay. Here we're starting at the end again. So I go 3, 6, 9, 12, 13, 14. And if you look, I don't have all these, like it's 9.80, but I don't want to put the 0. So it's just going to be 9.8 times 10 to the, 3, 6, 9, 12, 14.
So we just like skip the 0.
Yeah, you don't need to write that. Now, if this 2 was like an 8 or something, you could make that a 1 when you're rounding. But since when we round it, it stays a 0. We don't need to write zeros. They just go away. If we look at number 5, I need to move to the first, past the first not 0. So I need to move my decimal to here. So I'm going to count all of these. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's going to be 8 times 10 to the negative 11th. There's no decimal because there's nothing after the 8. Does it make sense? Why don't you guys try number 6? The best way I have done these, so I look at this number here, this is 5. That's how many places I have to move the decimal. So what I do is I just start counting. I write down my first digit, and then I say 1, 2, 3, 4, 5. If it's a negative, I write down my first digit, but I start backwards. These don't count because they're on the other side of the decimal and we're negative, so we're trying to add zeros out here. So I just write those down. Then I write down my first digit and I start counting with my first digit. I'm looking for 7, so I go 1, 2, 3, 4, 5,
The first
6,
digit
7.
after the decimal. Or you know what I'm talking about.
If you're going forward
right.
to make it bigger, I count starting here. So I wrote down the 2 and then I start counting 1, 2, 3, 4, 5.
Right. I understand.
When I'm coming the other way, because I'm going negative, these numbers don't get counted. So I write them down and I start counting with this number. So 1, 2, 3, 4, 5, 6, 7. Now, if that doesn't work for you, we can go a more traditional route. I can take the 3.63. Oops, I need more space on the other side because it's going negative. You have to keep that in mind too. When you've got a negative exponent, you're adding numbers in front of what you have, so you want to write it over here. When you have a positive number exponent, you're adding numbers at the end, so you'd write it here. So then what I can do is I need to move this decimal place 6 spaces. So I go 1, 2, 3, 4, 5, 6. Let me space that out a little better. Put the 9 over here. So I've got these 6 spaces, so I'm moving my decimal to there, and I'm adding all of these blank spaces to be zeros. So this is going to be 0.00000363. On number 10, I have a positive 8, so I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, and all of these will get filled in with zeros. 1, 2, 3, 4, 5, 6 zeros. Like that. So you can either just count it, or you can actually move the decimal by making like loops for the number of spaces you have to move it, and then fill each blank loop with a 0. Yeah.
So if you're doing it the other way around, obviously it's not the same number. Like if I come up with a number and then I put in scientific notation, then I try to put it back.
It's going to be rounded. It's going to be rounded, yeah. The scientific notation is rounding and shorthanding at the same time.
Yeah.
So with number 11, loopy method or county method? These are the technical terms, by the way, loopy and county. County, okay. So it's negative, so I'm going to start over here. I'm going to put my 8 and my 6 down. I'm going to start counting with the 1. So I go 1, 2, 3, 4. Okay, so I was a little far, but that's all right. Better to have too much space than not enough. And with 12, it's positive, so I'm going to start here. I'm going to write down the 4, and I start counting with the 9. So I go 1, 2, 3, 4, 5.
So it's always, I forgot what I was going to say. When it's positive, it's always you start counting after the point.
After the point, and when it's negative, you start counting with the number before the point.
Before the point.
Yeah, because you're going in the other direction. You count in the direction you're going. So you start with whichever number is on the correct side of the direction you want to go. Does that make sense? Or, like I said, or you can use the loopy method. Do you guys want to see a couple more of those?
So the number after the point, if it's positive, is
Notation is when you switch from these big giant, like, 20 trillion whatever times 50 gazillion. That's not a real number, but you know what I mean. Like,
or 13 or something.
If these really big numbers, are really hard to multiply all that, right? They won't even fit on your calculator. But when you multiply numbers in scientific notation, that allows you to multiply ginormous numbers times each other without actually having to multiply all those digits. So what you do is you multiply the decimal parts. Then you add the exponents on the 10. Okay. Multiplying the decimal part equals your new decimal part. Adding the exponents on the 10 equals your new exponent. Okay, so when I have an example like number 13, I have 6.1 times 10 to the 5th times 2 times 10 to the 5th. So I'm going to do 6.1 times 2. So this is number 13, which is going to give me 12.2. And then I'm going to add the exponents. So 5 plus 5 is going to give me 10. So what this gives me is 12.2 times 10 to the 10th. Now, this is not correct. It's almost correct. Sometimes there's a third step. Okay, where you have to adjust the decimal place and the exponent. If I have to move one more this way, I add 1 to here. So for each place I move to the left, I add another exponent. So this becomes 1.22 times 10 to the 11th. Because we can't have more than one digit before the decimal place in scientific notation. So we have to fix it. If we got 12.2, we have to make it 1.22. But because we moved one decimal place over, we have to add that here. Does that make sense? We'll do some more. On the same page, so we're still on the same paper. If we look at number 14, is 4.4 times 10 to the 6th times 1.6 times 10 to the negative 9th. So for the decimal part, I've got 4.4 times 1.6. Well, I'm going to cheat. So I get 7.04. For the exponent part, I have 6 plus negative 9. So it gives me negative 3. So my answer to this problem is 7.04 times 10 to the negative 3. This one I don't have to adjust because it's already in the right place.
But there's no such thing as negative exponents.
In scientific notation, you're allowed to have negative x. That's the only time.
Okay.
And that's because the negative exponent tells me this is going to be a decimal. Number 15, I'm hoping to get something that we have to fix.
We have to fix 17 or 15.
Okay, so I'm going to do the decimal part is 8.8 times 3.5.
I'm sorry, is that the part that 10, is that a 5 or an 8?
Where here?
Yeah.
8. It's on your paper, it's number 15.
Oh.
Okay, that gives me 30.8. And then the exponent part is going to be 8 plus negative 13, which is negative 5. So what this equals is 30.8 times 10 to the negative 5, but it's in the wrong place, so I have to move this one place, so I have to add 1 to this. So when I do that, it gives me 3.08 times 10 to the negative 4. If I were to have to move the other direction, just as an example, let's say I got something like 0.321 times 10 to the 5th or something. Okay. To fix that, I would be moving the other way. If I move the other way, I have to subtract 1. So if I move the decimal this way, I add 1. If I move the decimal that way, I subtract 1. I don't know if there are any like that. We'll do number 16, and then I'll let you guys try 17 and 18. So
The
Yeah.
only question is, with the exponent, it's 8 plus -13, but how do you know that you're supposed to put less?
you always add the exponents.
Oh, okay.
Yeah, you always add the exponents on these. So let's try 16.
And with this, it also allows like negative exponents.
Yeah, it's only scientific notation that allows the negative exponents, but this is still scientific notation, so it's okay. What we're doing right now, just to kind of give you an idea of the shortcut that we're taking, if we were to multiply this, like using the numbers without scientific notation, we'd have to multiply that.
I've done it for intensive math.
Yeah, but you don't want to, do you?
No, they don't let you use computers either.
Yeah.
I mean, calculators either.
And then think about this was rounded, so these were probably digits that weren't 0. So, you know, it'd be a lot of work, right? That's the whole point of this process. So it allows us to take this ugly mess and do this to it instead. So it's 9.72. This is the decimal part. And then the exponent part, I'm going to do 8 plus -4. It's going to give me 4. So my answer is going to be 9.72 times 10 to the 4th. And I did not have to do all this mess. So that's the beauty of scientific notation. It allows us to take these shortcuts. So first step, you divide the decimal parts. The second step, instead of adding the exponent, you subtract the exponents. And then the last step is you have to do that adjust if necessary thing. Okay, so this gives you your new decimal part, and this gives you your new exponent part. Okay, so if we look at, like, let's say like number 19, okay, I'm going to do 9.2 divided by 2. That's my decimal part, which is going to give me 46, 4.6. And then my exponent part, I'm going to do -8 minus -6. Okay? Minus negative becomes a positive, so that's going to give me -2. So my answer on this is going to be 4.6 times 10 to the -2.
Okay, I got that.
Okay. If we look at number 20, I'm going to have, for the decimal part, I'm going to do 4.8 divided by 3, which is going to be 1.6. Yeah. And then for the exponent part, I'm going to do 4 minus -5, which gives me 9.
4.8 divided by.
I think that's 1.6. Just do it in my head really fast, so it's probably not.
Yeah, you're right.
Yeah, okay.
How the hell did you get that in your head?
16 times 3 is 48.
Gotcha.
It's one of the ones I just happen to have memorized. Okay. We'll go to another page for number 21. Do the decimal parts first. So I have 1.161 divided by 4.3. And I am not even going to attempt to do that in my head.
0.27.
Okay, so 0.27. And then I have -9 minus -6, so that's -3. So this is going to tell me 0.27 times 10 to the -3rd, but I can't have 0.27. So I move this way, so then I subtract 1. If I move this way, I add 1. If I move this way, I subtract 1.
Okay.
So this is actually going to be 2.7 times 10 to the -4th. The decimal always has to come after the first digit. Yeah, exactly. Opposite of the number line. Okay. 22. I don't know if that one adjusts or not.
Can you go over number 21 again?
Yeah, hold on, let me just finish writing this one. This part?
Yeah.
Okay, because I got 0.27, right?
That was the answer when she divided.
That's the answer when I divide it. But I can't have 0.27. That's not structurally correct for scientific notation. Scientific notation has to be number, decimal, and then spaces.
That's what I mean.
Scientific notation, that's the way you do it. That's just the rule. So I have to have the decimal place here. So I have to move it 1 over. But because I'm moving this direction, I'm subtracting 1 that way. Basically, when you move, adding 1 if you move the other direction. Subtracting 1 if you move right, adding 1 if you move left. So that's where I got the -4.
So you just changed it yourself since.
Because it didn't work out correctly, I had to change it. Because it gave me a 0.27, so I have to adjust it to make it into proper scientific notation. I don't know if this one does or not. No, it doesn't.
You have number 23, you have to adjust.
23 I have to adjust? Okay. So this one's just going to be 3.7 times 10 to the 6th. And we're going to skip to 23 really quickly because it has to adjust. 23 is 2.376 times 10 to the -4th divided by 7.2 times 10 to the -8th. So I'm going to do 2.376 divided by 7.2. Yeah, that's definitely got to be adjusted. That's going to be 0.33. And then if I do -4 minus -8, that gives me a +4. So this, from my calculations, I get 0.33 times 10 to the 4th, but 0.33 is not allowed.
So it's 3.3.
Yeah, so I have to move this 1 place this way, so I subtract 1 there. So it becomes 3.3 times 10 to the 3rd. Now, remember how I said it was scientific notation makes division nicer? Look at what we would be doing if we were doing it this way.
Oh, no.
That's what this problem right here is not in scientific notation. Would you want to do that? No, that's ugly, right? That's what scientific notation makes things nice. Yeah.
-4 minus parentheses -8 equals 4. So whenever you're dividing, what you're doing.
When you multiply, you add the exponents. When you divide, you subtract them.
I thought it was just -4 plus -8.
Nope, that's when you multiply. If I multiplied these two, it would be -4 plus -8. But right now I'm subtracting. When you multiply, you add. When you divide, you subtract. Okay? So for the homework is going to be page 8 in the packet. Odds. Okay, that's just all scientific notation. And then the yellow paper, convert this. Scientific notation. Convert has an R in it.